All right, hello and welcome to lesson 4C. Today we're going to be solving with substitution again, day 2. So today we're going to get some more practice at this. I know this is a new method for you, so let's go ahead and look and see what we have here. I'm actually going to have you start down here on this one, on y equals 5 and 2x plus 3y equals 29. Now remember, what we're looking for is an ordered pair. We're looking for both an x and a y. That works for both equations. Now this one's a nice easy one to start with because they're already telling us that y equals 5. So I have that part. Y is equal to 5. So I'm going to circle the fact that the y is isolated. That y is by itself. So what's across from it is exactly equal to y. So any y's I see are going to equal 5. So I'm going to circle where I see y down here. And I'll know now, because y is equal to 5, that I can replace this y with a 5. That's substitution. Substitution is replacing things. So I'm going to rewrite this second equation now, 2x plus 3, but instead of y, I'm going to write 5 equals 29. Now it's a simple little equation that I can solve. So this now would be 2x plus 15 is equal to 29. Draw the line, circle the variable. You remember how to do all this. We'll subtract 15 next from both sides, which means we'd have 2x equal to 14. Divide both sides by 2, and we get x is equal to 7. All right, but let's go ahead and check that. So we're saying that x should be 7 when y is 5. In the first equation, that's easy. I'm going to replace just the y because there's no other variables. So let's call this our check. We need to be checking all of these things. So the first one says y equals 5, so I'll replace y with the y that we have. So that means 5 equals 5, and that checks out. That one's easy. But let's check the second one. That's a little bit harder. So the original equation said 2x plus 3y should equal 29, which means 2 times the x we got, which was 7, plus 3 times the y we have, which is 5, should equal 29. 2 times 7 is 14, plus 3 times 5 is 15, and it should come out to 29, and 14 plus 15 is 29, and so we know, since this one point worked in both equations, we know that it is the actual answer. Don't forget to check your work. If you check it, then you know you'll be right. All right, so that's the easiest kind. Now let's go to the second easiest kind. Back up here towards the top. I'm going to have you move to this one. This one tells me y is equal to 3x, and y plus y is equal to negative 12. All right, so to figure this out, I see a y by itself. That means y is equal to 3x's. So y is equal to 3x's. Now, this time, it's not just a number, so it's not quite as easy, but I can still replace any y I see with 3x's. So that means I can replace it here and here. So I'm going to rewrite this y as 3x, and I'm going to do the same thing with this one. I'm going to write it as 3x, and together those will equal negative 12. Now I see some terms I can combine, so 3x plus 3x would be 6x is equal to negative 12, and if I divide both sides by 6, I see that x should be equal to negative 2. All right, so I know part of my point. Remember, my point always has an x and a y. So I know part of the point is negative 2. Now I just have to figure out the y. Well, I could figure that out a number of different ways. I'm going to plug it in. I'm going to plug in this negative 2 in this equation up here, which was originally y equals 3x. Now that I know x is negative 2, I can write y is equal to 3 times negative 2. And 3 times negative 2 is negative 6. So I'm saying the point that works for both of these equations is negative 2, negative 6. Let's make sure that works. So here's our check. The original equation, first one, was y equals 3x. I'm saying y is negative 6 when x is negative 2. Let's see if that works out. Negative 6 should be equal, let's see, 3 times negative 2 is negative 6. So it works for the first equation. Let's make sure it also works for the second. The second equation was y plus y equals negative 12. I said that y is negative 6, which means negative 6 plus negative 6 should equal negative 12. And let's think about that. They're both negative, so we add them up, and we do get negative 12. All right, because this one ordered pair worked for both of the equations, we know it's correct. I really want to see you guys check your work today. All right, let's try this one down here. I see a variable by itself. So I see x is all alone, isolated on one side of the equation. So whatever's across from that can be replaced for x. So I can replace any x's with a 4y. I see x in the second equation right there. So I'm going to rewrite that as 5 times, instead of x, I'm going to write 4y. So 5 times 4y, and then I'll continue, plus y is equal to negative 42. All right, so 5 times 4y is going to give me 20y, plus another y equals negative 42. Well, 20y plus y is going to be 21y equals negative 42. Dividing both sides by 21 actually works out pretty nicely. Negative 42 divided by 21 is going to give us negative 2. All right, so we know part of our point. Remember, we're always looking for an x and a y. So we figured out y is negative 2. Now I just have to figure out x. I can plug this into either of the equations since they're equal. It should come out equal for either of them. The top one just looks a little easier. So I'm going to write down x equals 4 times y. I now know y is negative 2, so I'm going to write x equals 4 times negative 2, and 4 times negative 2 is negative 8. Okay, so my answer, the point that should work for both equations, is negative 8, negative 2. Here's the check. Don't forget to write this in today. We're going to write the first equation, x equals 4y, with plugging in our x and our y, both parts of our point. Let me zoom out a little bit so we can see that all at the same time. There it is. So instead of x, I'm going to write negative 8 should be equal to 4 times, instead of y, I'm going to write negative 2. So negative 8 should equal negative 8, and that works. Now let's try the second equation. 5x plus y equals negative 42. So I'm going to rewrite that without any variables because now we know what they equal. X is negative 8 when y is negative 2. And hopefully that comes out to be negative 42. Let's check. 5 times negative 8 is negative 40 plus negative 2 should equal negative 42. And two negatives here. Yep, everything's all negative. Nothing cancels out. So we get negative 42 is equal to negative 42, which means our answer is correct. It worked for both equations. All right, let's try this first one up here. I see a y by itself. I'm going to circle it because it's all by itself. This expression can be replaced or can be used to replace y. So I see another y down here, so that's where I'm going to replace it. So I'm going to write 3x plus, but instead of y, I'm going to write what y is equal to, which is 2x plus 1. And then I'll complete that equation, equals 21. All right, so we have 3x plus 2x, which is 5x plus 1 equals 21. I'm going to subtract 1 from both sides to get 5x equals 20. Divide both sides by 5, and x equals 4. All right, so we've got the x part of our point. We know x is 4. Now you'll notice I always do this. I always label the x and y so that I remember which variable I just got and where it goes in an ordered pair. So I'm going to write the 4 under the x. So we know x is 4. Now we just have to figure out y, but now that I know x, it's a lot easier. I'm going to use this top equation. Again, it just seems easier to me. So y equals 2x plus 1. I now know x is 4, so y will equal 2 times 4 plus 1. And 2 times 4 is 8. Adding 1 gives me that y is equal to 9. Okay, so I'm saying that's the answer. Don't forget our check. I want to see you check everything today. First equation is y equals 2x plus 1. We're saying y is 9 equals 2 times x is 4 plus 1. So 9 would equal 8 plus 1, and 9 equals 9. So it checks for the first equation. Now the second equation, 3x plus y equals 21. That means 3 times 4 plus 9 should equal 21. 3 times 4 is 12, plus 9 should equal 21, and 12 plus 9 is 21. Check. So we know because our answer worked for both equations, it is the correct answer. I know the check takes a little while, but if something goes wrong and it doesn't check out at the end, that means you've got to do something differently up here. Something went wrong and it didn't come out equal. So you should always be checking your answer. Let's keep trying. Here's the back page. I see a y by itself down there, so circle it. Y is equal to this whole expression, and I see a y in the other equation, so I can replace that. So let's write that equation, x plus 3, but instead of y, I'm going to write x minus 2 equals negative 10. Now that it's all the same variable in the equation, I can work it out. Remember, this means to distribute whenever you have a whole group being multiplied by a number. You've got to multiply everything in that group. So this is going to be x plus 3x minus 6 equals negative 10. X plus 3x is 4x minus 6 equals negative 10. Remember all this from Unit A. We've done this a long time ago. I'm going to add 6 to both sides to get 4x equals negative 4. Divide both sides by 4, and we get x equals negative 1. All right, so the first part of our point is negative 1. Now we just have to figure out the second part of the point. I'm going to use this second equation just because it looks easier in my opinion. I'm going to replace the x with what I know it is now, negative 1, and subtract 2. Or in other words, add a negative 2. So y will equal negative 3. All right, so I'm saying that our one and only answer is negative 1, negative 3. Don't forget to check. So the first equation is x plus 3y equals negative 10. X, I'm saying, is negative 1 plus 3 times negative 3 should equal negative 10. That means negative 1 plus negative 9 should equal negative 10, and it does. So it checks out for the first one. Now the second equation. Y equals x minus 2. I'm saying y is negative 3 when x is negative 1, and that does work out to negative 3 on both sides. So we know we're correct. All right, let's try one of these. This will be the last one I talk about in the video, but really everything else is pretty much the same. I see a y by itself here and an expression that it's equal to. And I see a y by itself over here. But all that means is I can replace these, and we saw this yesterday. So x plus 1 is equal to 2x minus 3. That's what it comes out looking like. It's just these expressions are set equal to each other. When I draw my line and circle my variables, remember back in Unit A, we want to move the one that's smaller if we can. To move it, we subtract it from both sides. Remember, to get across this line, you have to do the opposite. So 1 will be equal to x minus 3. We add the 3 to both sides, and we get 4 is equal to x. All right, so there's one part of our point. We know the x part is 4. Now we just have to figure out the y, but it's easy. Now that we know x is 4, y will be equal to 4 plus 1, which means y is equal to 5. Now for our check. Excuse my cough. First equation is y equals x plus 1. So that means 5 should be equal to 4 plus 1. And it is, so it checks out for the first equation. Second equation would say 5 is equal to 2 times 4 minus 3, which means 8 minus 3, which is 5. All right, try your exit ticket. Don't forget to ask me questions if you've got them. Good luck. Yay, math.